We're moving on to a new unit of study here and talking about graphing, specifically talking about graphing linear equations. That doesn't mean that we could just toss everything out that we learned about solving linear equations. We're still going to have to use that stuff. In fact, we're going to have to use that in this exact lesson. But we are moving on and trying to extend that to graphing. The first thing that we need to be able to do is plot points. The way that we're going to graph in this lesson is by graphing points, plotting points and drawing a line through those points. Every point is a x comma y. It's important that the points go in that order. One way to remember that, it's in alphabetical order. The x comes before the y, w, x, y, z. X comes first, y comes second. The x coordinate tells you how far left and right you're going to move, and the y coordinate tells you how far up and down you're going to move. We're going to see a lot of examples of this today, and we're going to use those points. Every point has an x and a y. We're going to use those points to draw equations of lines. We're just going to do a few of these. We're not going to do every single one of them, but if I draw my x and y axes, so let's say this is the x-axis, and let's say this is the y-axis here, then this first point, 4 comma 5, that's 4 for the x and 5 for the y. Every point, remember, x comes first, then y. 4 for the x, that's 1, 2, 3, 4. I move 4 over in the x direction. Here, let me grab my little glowy thing here. Move 1, 2, 3, 4. Then I need to move up 5 in the y direction. That's positive 5. 1, 2, 3, 4, 5. And now I can mark that grid, that intersection of that grid, with a point. The same thing with negative 4 and negative 5, except for this time I'm moving in a negative direction, right? I'm not moving in a positive direction. Negative means I'm moving to the left. And so I'm moving negative 4 in the x direction means left 1, 2, 3, 4. Negative 5 means I'm not going up, but I'm going down 1, 2, 3, 4, 5. And now I need to mark that point on my graph. All right, let's choose another one. Here, I'll mark this one in red. Negative 1, 3. Notice I'm moving negative in the x direction, negative 1. Still positive in the y direction, 1, 2, 3. So I moved negative 1, 3. And that's where I ended up. That's where my point is. How about 3, negative 1? I challenge you to just pause for a second and think about 3, negative 1. 1, 2, 3. Positive 3 in the x, negative 1 in the y. We land right there. All right, we'll just do one more of these. The point negative 2, 0. I'll move negative 1, negative 2. Think about how far are we going to go up or down? We're going to go up or down 0. We're not going to go up or down at all. And so we actually just land directly on that grid. And I said one more, but let's do one more. The point 0, 0 means left or right 0, up or down 0. So that is the origin. The origin is the point 0, 0. All right, here we have a map drawn. All of the ranger stations are dotted to A, B, C, and D, and they're all within the map. They're all within the national park. It wants the actual coordinates of each of these points. Estimate the coordinates of these points. So for point A here, what are the coordinates for point A? Well, it looks like I go left 1 and down 3. So point A is at negative 1, negative 3. Left 1, down 3. Point B, I went left 2 and up 3. So left 2, up 3 is point B. Point C, we're just trying to estimate here. I could say I went right 1, 2, 3, and a little bit, maybe 3.5, and up 1 and a little bit. So we'll call it maybe 3.5, 1.5. We don't have to be totally accurate here. The question does say to estimate. And finally, point D, looks like I went over 1.5, over 1.5, and I went down a full 2. All right, we're trying to use this idea to graph lines. We have to be able to graph points to be able to graph lines. A linear equation, so we've talked about it in the last unit, linear equations in one variable, things like ax plus b equals c, where we could solve for x. We're trying to solve for x and get a number, right? So a lot of times we would get just x equals -2. This equation, we would subtract the 5, divide by the 3, we would get x equals -2. What we're looking at now is a linear equation in two variables. Notice now we don't just have an x, we have an x and a y. The x and the y are both important because those are going to give us our xy coordinate that we can graph. Any line has infinitely many of those coordinates. So I could have it on a line, we have a bunch of coordinates. I could have a x equals 1, x equals 2, x equals 3, and have a different y coordinate for each. The equation, look at this equation right here, x plus y equals 4. That is a linear equation in two variables, right? It's a linear equation. It has 1, 2 variables, x and y. There are a bunch of solutions, like I said. The solution 2 comma 2 is a solution, and I know that it's a solution because if I plug it into the equation, x plus y equals 4, 2 plus 2 equals 4, check. 1 plus 3, yes, that equals 4. 4 plus 0, that equals 4. This is demonstrating what I was saying earlier. I'm sorry about the chicken. There's a chicken right off my porch. This is demonstrating what I was saying earlier, that any line is going to have a lot of these solutions, right? It's not just necessarily one specific solution. If you graph all these points individually, these points right here, so just like we were doing in the last little section, the point 2, 2 is right there, the point 1, 3 is right there. If you can get any 2 points, you can make a line. This has given us more points, and notice that all those points are falling on the same line because they came from the same equation. But if you can find 2 good points, then you can graph a line. That's going to come up again here later. All right, for the linear equation 6x minus 5y equals 12, determine whether each point is a solution. Here's how you tell if it's a solution. You have a x comma y. Remember, it's in order, x, y. You're going to sub those in. 6 times x minus 5 times y equals 12. I'm subbing it into this equation here. 6 times 2 is 12, minus 0 equals 12. 12 equals 12. If you get a true statement, then you have a solution. That means the point 2, 0 is a solution. Let's check this point 3, 1. 6x minus 5y equals 12. 6 times 3 is 18, minus 5 equals 12. I get 13 equals 12. That's not true. So that means that that point, 3, 1, is not a solution. And one more example here. We've got the point 1, comma, negative 6 over 5. So that's 6 times x minus 5 times y. I'm going to use the calculator here. Negative 5 times negative 6 over 5 is positive 6. 12 equals 12. Check. That means the point 1, negative 6 over 5 is a solution. Now remember I said that you only really need 2 good points to plot a line. When I go to graph this line, if I was going to graph this now, I would plot this point, I would plot this point, I would not plot that point. You only need 2. If you get one that's a fraction or something like that, a fraction or a decimal, I just wouldn't graph that. If you only find 2, and one of them is a fraction, I would try again and find one that's not. So let's graph those points here. The point 2, 0 means I need to go right 2, up 0. The point 3, 1, oh wait, 3, 1 is not a solution, so I'm not going to graph 3, 1. That's not a solution. The point 1, negative 6 over 5, that's negative 1.2, is right in this range. And there's my line. Remember, we only need 2 points to graph a line. I missed my points there. I'm not an artist. That's the line. And the line is 6x minus 5y equals 12. 6x minus 5y equals 12. That's the line that I graphed there. I didn't graph this point because it is not a solution. All right, take a second and check these, see if they're solutions. I'm going to give you just a couple minutes to work. In 3 seconds, I'm going to erase my little lines here, so pause the video if you need to. Is 4, 0 a solution to this equation? It seems that it is not. I got 12 equals negative 12. That is not a solution. 3x minus 2y equals negative 12. Negative 2, positive 3 is a solution. Positive 1, positive 15 over 12 is a solution. So when we got it ready to graph this line, we would be graphing those 2 points and not graphing that point. All right. This is showing the exact same thing that I was just showing you. We're going to find points. The way that we're going to do it, a lot of times people like to make this, it's called a T-chart, right? A T-chart shows you what the points are, and these numbers that we put in here, there's no reason why we pick these numbers over other numbers. They're arbitrary. You can pick any numbers that you want. A good starting point, a good starting point typically is to put in 0 for x and to put in 0 for y. We're going to see why that is later. For now, we're just going to use the numbers that they gave us. So 2 comma blank. 2 comma blank is what we're saying for the T-chart. They gave us 2 for x, and we want to find y. So let's see, a 2 for x minus 2y equals 8. I put in a 2 for x here. I could subtract the 2. This is where our unit 1 knowledge has to come in. Divide by the negative 2. And we get y equals negative 3. So at this point, 2, negative 3. The next one, they didn't give me x. They gave me y, right? I'm looking in, this is the y column. In the first one, they gave me the x column. This time, they gave me the y column. So here I'll say x minus 2 times y equals 8. I'm just always going back to that original equation and subbing in what they gave me. If they gave me x, I'm going to sub in x. If they gave me y, I'm going to sub in y. Subtract the 2. And x equals 6. That's 2 points already. We could stop there. Let's go ahead and try and solve for this one. They gave me x, so that's 0 minus 2y equals 8. 0, if we subtract 0 from both sides, we just get negative 2y equals 8. Divide by the negative 2, and we get y equals negative 4. All of those are fine. All those are fine points. They all work. We made sure that they worked. The way that we plugged them in ensures that they worked. And so we can plot those 3 points. I wish I had a little more space here. Here, we'll squeeze it in right here. We can plot those points here. The point 2, negative 3, I'm going to plot in blue. The point 6, 1, I'm going to plot in this purple color that we have. And then finally, the point 0, negative 4, I'm going to plot in the same pink color that I did earlier. These 3 points should all land on the same exact line. Again, I'm not an artist. I'm sorry, my line's a little squiggly here, but they should all land right on the same line. If you ended up with numbers here that were not nice, you only need 2. You only need 2 points. So if you ended up with fractions or decimals, you just would not graph that point. All right, so usually we try to choose, like I said, arbitrary values. It doesn't matter what the values are that are going to go in the T-chart. We get to pick what we want. But generally, a good rule of thumb is to start with 0 and 0, and then we can go from there. If we need more points, then we can add more points. If we get a fraction for one of those, or if we get matching values or something, we can add more points. All right, let's try and figure this one out. If we put in a 0 for x, that's 2 times 0 plus y equals 6. 2 times 0 is 0. So then y equals 6. See that worked out very nicely and quickly. And let's plug in 0 for y. 2x plus 0 equals 6. Again, that's just 0. So 2x equals 6. So then x equals 3 when I divide by 2 on both sides. And now that I have 2 nice points, I could keep going. I could add numbers here if I wanted to. And it does not matter what those numbers are. You get to pick. This is just a good starting point. Once you have 2 points that work out nicely, though, you can graph. So the point 0, 6, 0 on the left and right x-axis, and 6 on the y-axis. That is this point here. And the point 3, 0, that means 3 left and right, up and down 0. That's this point here. So my line is going to go through those 2 points. That's what my line looks like. Here's one for you to try. Pause the video and see if you can figure out these values. These are the values that I got. I got 5, 3.75, and 1. If you were looking at this and seeing which ones you did want to graph, I would absolutely graph the 0.05. That's a nice number. I would not graph the decimal. I would skip ahead and graph the 0.31. I'm not a fan of graphing those decimals. They just make things a little bit more difficult, tedious. And so that's our line. So notice I did not graph the purple point because it had a decimal in it. Try this one. Hopefully you made a T-chart and started throwing values on your T-chart. I chose 0 and 0. Those are some good first choices. When I went to solve, 0, 0, 0 for x, 0 for y, 3 for x, this is what I got. I got 3 nice numbers. So I didn't have to go any further. I didn't have to go and choose a third. I didn't have to put 3 in there. But when I put in 0, I got out 4. When I put in 0 for y, I got out 6 for x. And when I put in 3 for x, I got out 2 for y. Let's graph those points, make sure they land on the same line. 0, 4, 6, 0, and 3, 2. That's right 3, up 2. And it looks like they all land on the same line. My artistic abilities finally played off here. And that's what our line should look like. All right, there is another way to graph equations. We're going to see more of this later in the unit, but know that when we get to that, you can always come back to this. You can always come back to subbing in points and finding what works, right? Again, you're just choosing numbers. It doesn't matter what the numbers you choose. You're trying to get numbers that don't make decimals. But this one is actually in this form, y equals mx plus b. So I'm just going to give you a taste of this right now. If you don't get this first try, that's perfectly fine. Like I said, we're going to do more of this later in the unit. So when it's in y equals mx plus b form, b is your y-intercept. I'm going to show you in just a minute how to solve for a y-intercept, but if it's already in this form, that is your y-intercept. Notice I labeled my y-axis, so my y-intercept is 1, right? That's the b part. That's where it's going to touch that y-axis. The m is your slope, and the slope tells you how far to move once you've found that point. So my slope tells me that I need to move down 1 over 3. The slope is always your rise over run. Again, we're going to do this more later. That means I'm going to go down 1 over 3. So I'm just giving you this, like I said, just as a flavor for what's coming. Notice that I did not have to go through the T-chart, but if I did go through the T-chart and start subbing in, I would get the 0.01 and the 0.30, and those are exactly the points that I have graphed already. Those are exactly my pink and my blue points that I graphed using the y equals mx plus b form. All right, I was talking a second ago about finding the y-intercept, finding the y-intercept specifically, but we can find the x and the y-intercept. The same strategy works for both. We're just going to flip what we're doing. So anytime you want to find this, notice how many stars I have here. This is very important. This is something that comes up over and over again in pre-college algebra and in college algebra and in higher math. Anytime you want to find an x-intercept for any equation, you're going to set y equal to 0 and solve. Anytime you want to find the y-intercept for any equation, you're going to set x equal to 0 and then solve, okay? So you're subbing in for the opposite variable. To find the x-intercept, set y to 0. To find the y-intercept, set x to 0. Let's try that out. For this equation here, if we want to find the x-intercept, we're going to set y to 0. So I just put a 0 in for that variable there. 2 times 0 is 0. Divide by the -3. And I get x equals -8 over 3. It's okay that it's a fraction. Find the y-intercept. That means I'm going to sub in a 0 for x. -3 times 0 is 0. I'm going to divide by 2 and get y equals 4. Those are my x and y intercepts, and I can use those to graph. Even though that x number is not very nice, I can estimate that in the calculator. Negative 8 divided by 3 is negative 2.66. So I can use some estimation here if I need to. My y-intercept, very nice, y equals 4. My x-intercept is negative 2.66. That's before you get to negative 3. Some questions will ask you specifically to graph using the x and y-intercept. That means you have to use those 2 points. And you'll just have to, on Alex, estimate where negative 2.66 is. It's between negative 2 and negative 3. Here's another one for you to try. Find the x-intercept. I'm going to erase that. Find the y-intercept. Here's your y-intercept. I added those to a t-chart just so you could see how it would look. And notice that I got a fraction. That's okay. We can graph that fraction, or we can pick another number that doesn't make a fraction. So that 4.33 is about, I'm sorry, the 4 over 3 is about 1.33. So that's a little bit over 1. And x-intercept is negative 4. That's this point right here. Notice that's still, I can still do the same thing as I was doing with the t-chart. And then if I wanted a better point, just to make myself certain, I could plug in 2 and see what I get out, right? Trying not to get a fraction. That 2, like I said, is just an arbitrary number. I just picked a number. I chose a number that I thought would work well, but that's just something that comes with practice. You just keep choosing numbers until you don't get a fraction, if that's what you'd like to do. Same thing, take a second, try this one. I'm going to erase my work in about 3 seconds. I got x equals 0 and y equals 0. Notice when we put those in the t-chart, let's see what happens. We get the point 0, 0, right? And if we put a y in for 0, we get 0. We actually get the same point. The blue point is here. The y point is here. We don't have 2 points, so we actually will have to get another point to be able to graph this. And I just chose 5 for x, so I'll say, again, going back to my original equation, 4 times 5 minus 5, plus 5 times y equals 0. That's 20 plus 5y equals 0. Subtract the 20. We get 5y equals negative 20. Divide by the 5. And we get y equals negative 4. So we can now plot this point. Here, let's pick a different color. The point 5, negative 4. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4. And I chose this yellow color. And so now we actually do have a second point. Sometimes that does happen, that your x-intercept and your y-intercept are the same thing. That's when it lands on the point 0, 0. They'll be the same thing. And then you'll just have to go and find another point. One more topic here is vertical and horizontal lines. Anytime you see an equation that you have to graph that only has an x, it doesn't have a y, then it is going to be a vertical line. That's x equals 5, x equals 10, 2x equals 10. It can have other numbers, but if it only has an x and no y, it's going to be vertical. If it only has a y and no x, then it's going to be horizontal. Y equals 5, 10y equals 20, right? Anything with just a y and no x is going to be a horizontal line if you're asked to graph it. Graph in the equation y equals 3. If we wanted to, we can make a t-chart, y equals 3. Well, what do we know? We know y equals 3, right? For any point, y equals 3. That's what our equation tells us, is that y equals 3. If I go to y equals 3 and put a point, right, that's the point 0, 3, and I set up above that a horizontal line is always going to be y equals a number. This is going to be a horizontal line. It's going to go directly left to right across. That's going to be my line. Notice that does go through the point 1, 3, and the point 5, 3, and the point negative 1, 3, right? All those points are on that line. Y equals 3 all the way across that line. So anytime you see a y equals a number, it's going to be horizontal. X equals a number, it's going to be vertical. That's anytime there's no y in the equation, it's going to be a vertical. If there's no x in the equation, it's going to be a horizontal. Here's another example. It looks a little different, but notice there is no y in this equation. If I solve for x, divide by 7, I get x equals negative 2. Still, there's no y in this equation. And so x equals negative 2 is a vertical line, we said on the last slide, because my t-chart would look something like this. I would have everything, x is negative 2 everywhere. X is negative 2, x is negative 2. I would have negative 2, 0, negative 2, 1, negative 2, 5, negative 1. It doesn't matter what numbers I pick, x is negative 2, right? That's the end of this lesson. Again, we're going to keep graphing throughout this unit. We're going to graph other types or equations in different forms and see another way to graph later on.